I'm Miss Ulrich, and in this video I'm going to teach you how to transform linear relations into a table, a graph, decide whether it's increasing or decreasing, and identify the y-intercepts. So let's start with this first problem here. This is a negative 3x plus y equals 1. So remember, before we have to do anything, before we are able to plug it in on the calculator, we have to put it into y equals form, meaning all other variables are on one side and the y is by itself. So there are steps to this, as we learned in the last video. I'm going to go over those steps again. So you should remember from the last video these steps. So the first step, we're going to add or subtract the x term. So in this case, our x term is a negative 3x. So I'm going to get rid of that by adding 3x to both sides. Now again, when I add it over here, I do not combine it with the 1 simply because those are not like terms. So the x's on the left will cancel out. Let's bring down a positive y, or just y, and then these come down separately. This is step 2, so we're going to bring down positive 3x and then plus 1. And because there's no number technically in front of the y, it's just a 1, this is our equation. So we're going to use this equation now and plug this in on our graphing calculator. So after we take this equation, y equals 3x plus 1, and put it in our calculator and look at the table, we see that we get several x values and y values as a result. So remember, I told you to keep the numbers small, that way it'll fit on your graph. You always want to look at some negative and some positive. So I'm going to go ahead and use the same numbers that I've told you to use before. So in our table, we're going to use negative 2, negative 1, 0, 1, and 2. Okay, so based on my calculator, my table, my calculator, when x is negative 2, y is negative 5. When x is negative 1, y is negative 2. When x is 0, y is 1. When x is 1, y is 4. And when x is 2, y is 7. Okay, so after I have my table, I can plot my points on my graph. So we can plot the first point, negative 2, negative 5 would be down here. Then we have negative 1, negative 2. Then we have 0, 1. And then 1, 4. Okay, obviously that 2, 7 is not going to fit on my graph, and that's okay. The rule of thumb is to get at least 3 points on that graph, and go ahead and connect your dot to make the solid, straight, linear graph. Keep in mind that we are dealing with linear equations from here on, so if it's not making a straight line when you connect the dots, you probably graphed it wrong or plugged it in wrong. So keep in mind, again, it should be a straight line. So I want to look at a couple things now based on this graph that I want you to be able to identify. And the first thing is it increasing or is it decreasing? So an increasing graph means our numbers are going up from our table. So we can look at this and judge based on what's happening on our table. So you should notice here that the numbers are increasing by 3 every single time. We also can tell that our graph has a constant increase. The numbers are going up. So therefore, overall, this graph is increasing. And again, that's because we show a positive rate of change and a positive graph, just like a positive correlation. Now, the other thing I want you to determine is the y-intercept when we look at our graph. So we've talked about the y-intercept a little bit, and it's going to become very important when we write this. So again, the y-intercept is where it crosses the y-axis. So when I look at my y-axis here, I'm looking to see where the graph crosses this point at. And notice that it crosses right here at 1. Now remember, that is a coordinate. I want you to write it as a coordinate. So that point there is actually at 0, 1. And we notice it in our table as well. You always should. It's where the x value is 0. So therefore the y-intercept is 0, 1. It is increasing. And now I have my table and my graph based on my equation. And again, I can find all of that just by plugging it in on the calculator. All right, so let's try another one to put it in these different formats. So this second equation is 5x minus y equals 10. And again, I want you to solve it for the y value in order to get y by itself to plug in on your calculator. So remember, these are the steps that we've talked about. The first step, you're going to add or subtract the x term. And our x term here is this positive 5x. So if I want to get rid of that positive 5x, I'm going to have to subtract 5x from both sides. Remember, when we subtract it from the other side, we're not combining it with that 10 that's already there. It comes down separately. So step 2, bring everything down. I am going to bring that negative y down, and you have to understand, first of all, that that is actually a negative 1y. That becomes very important when we look at linear relations. So we have negative 1y equals negative 5x, and then plus 10. Again, those come down separately, and it is a positive 10 because it does not have a negative in front of it. It's understood to be positive. So that's the second step. Third step, we're going to divide everything by the number in front of y, which in this case is a negative 1. So I'm going to divide everything in this equation by a negative 1, which is basically going to flip the signs of everything. So we're going to now have y equals negative 5 divided by negative 1 is going to give us a positive 5x, and then a positive 10 divided by negative 1 is a negative 10. So the equation this time is going to be y equals 5x minus 10. So this I'm going to take the y equals 5x minus 10 and I'm going to plug it in on my graphing calculator and look at the table that it comes up with. So again, in my table, it should look like this. When we have a negative 3, the y value is negative 25. When the y and the x value is negative 2, the y value is negative 20. Now understand, those are some really big numbers here, and that's going to be hard to graph, and we're not going to get as many points on here as we usually get. But the rule of thumb is that you should be able to at least get 3 points on your graph. So I'm going to go ahead and use the same numbers that I've been using, negative 2, negative 1, 0, 1, and 2. And I'm going to go ahead and copy the y values down. So we have negative 2, negative 20, negative 1, negative 15, 0, negative 10, 1, negative 5, 2, and 0. And I'm going to go ahead and extend it one more. Let's go ahead and put 3, 5 on there. That way I can fit it on my graph. So really the only 3 points I'm going to fit on here are that 1, negative 5. So let's start there. We have 1, negative 5. Then I have 2, 0, which would be right here. And then 3, 5. So again, those are the only 3 points I'm going to fit on my graph. Go ahead and connect them. And again, put arrows on the end to show that it does continue to go in either direction. What's happening here is this is a broad range to where it's increasing, and my graph is just really small to show it, but that's okay. So I want you to, first of all, look and determine, is it increasing or is it decreasing? So looking at our numbers here, what's happening in the table, we are increasing and we're adding 5 every single time. So therefore, this graph is increasing again. And then we have, we need to look for our y-intercept. So remember the y value, or the y-intercept is where it crosses on the y-axis, this axis right here. Well, first of all, it's kind of hard to see based on my graph just because my graph didn't extend all the way. But we've talked about before how the y-intercept is where the x value is 0. So if you look on your table here, the x value is 0 when y is negative 10. So therefore, when I'm trying to find my y-intercept for this, the y-intercept would be at the point 0, negative 10. And again, if I looked at my graph on the calculator and extended it, I would be able to see that it crosses at negative 10 on the y-axis. So again, use your calculator to help you answer several of these questions. All right, let's try this equation this time. So we have in this one 2x plus y equals 0. Remember, the first thing I always have to do is solve for the y value. So I'm going to do that by following these steps here. So the first step, we're going to add or subtract the x term, and the x term in this case is this positive 2x. So let's go ahead and subtract the positive 2x by minusing 2x from both sides. When I subtract 2x from the right side, keep in mind that 0 and that negative 2x are not going to combine. They come down separately. So let's cancel this out. I'm going to bring that positive y down, which is really just a y, equals, and then we have negative 2x, technically plus 0. Now, because I have no number in front of the y here, it's understood that it's a 1, and 1 isn't going to change it. This is really it. This is my whole equation. So we have y equals negative 2x. Now, I really don't need to bring this 0 down just because it doesn't change anything about the situation. So I'm going to leave it off. This is really all I'm going to use. Y equals negative 2x is what you can now plug into your calculator. So when plugging this equation into our calculator, y equals negative 2x, we're going to get a table that looks like this. And again, we're going to copy the same points into our table on our paper. Now, Again, you can choose whatever points that you want to use. I just always recommend small points, positive and negative, close to 0. So I'm going to go ahead and use the same ones I've used before. -2, -1, 0, 1, and 2. So here we have when the x value is -2, the y value is 4. When the x value is -1, the y value is 2. When the x value is 0, the y value is 0. When x is 1, the y value is -2. And when x is 2, the y value is -4. Okay, and we can go ahead and graph those on our page as well. And we can put all of them on here actually. So we have -2, 4, -1, 2, 0, 0, 1, -2, and 2, -4. And I'm going to go ahead and connect those points as well now to see what the total graph looks like. Again, it should make a linear equation because we are talking about lines here. So 2 things I want you to determine. The first thing, is it increasing or decreasing? So what you should notice across your table here is that the values are going down by 2. So they're decreasing by 2 each time. You'll also see that there's a general pattern where it goes down. So this one is actually a decreasing graph. It would kind of be like a negative correlation. It goes down. So now we need to determine where is the y-intercept. And again, the y-intercept is where it crosses the y-axis. So in order to find that, we're looking for one of 2 things. Either on my table, I want you to determine where the x is 0, or on the graph, I want you to see where it crosses the y-axis. And notice it actually crosses right here. On our table, we see that point right here. So the y-intercept is actually right at the origin at 0, 0 for this one. Okay, so let's look at this last one now. Here we have the equation y equals 2. So normally I would start by putting it into y equals form, but this one happens to already be in y equals form. So I'm going to look at this by just plugging it into my calculator now in my table. Now, notice there's no x value with this one. It's just y equals 2. So when you plug it into your calculator, all you're really plugging in is a 2 in the y1 position. Alright, so after I plug it in on my calculator and I look at my table, this is what you should have seen. What you should notice is that the y values are all 2. No matter what the x value is, it stays the same. And that's simply because it doesn't matter what the x value is, because in our equation it said just simply y equals 2, and that's it. So when we plug in numbers to graph, I want you to go ahead and use those same numbers. So we have -2, -1, 0, 1, and 2. The difference here is that the y values are all 2. So again, it doesn't matter what the x is, the y is simply 2. So I can go ahead and graph these still just like I would any other. So I have -2, 2, -1, 2, 0, 2, 1, 2, and 2, 2. So what you should see here is that when we connect it, it makes a completely horizontal line. And therefore, when I ask you whether it's increasing or decreasing, well, it's neither. There is no change. And this is what we've referred to as a constant graph. There is no change up or down. It's just a constant situation. Again, it's increasing by nothing each time. It's just 0. So this is constant, and when we look at now the y-intercept, I'm still going to look to see where it crosses the y-axis. And again, you can find that one of 2 ways. We can look and see where it crosses this line, which is right here, or we can look at for the x value to be 0 in our table, which is right here. So when I ask you for the y-intercept for this equation, I want you to tell me that the y-intercept is at this one on 0, 2. So that's where it crosses on the y-axis. It'll help you to understand how to make connections among linear relationships. Now remember, the calculator will do so much for you as long as you know how to use it and plug it in correctly. Make sure you ask questions in class and review the video if you have any further questions. I'll see you next time.